So guys, welcome to chapter 3. In this chapter I like to start playing with a pop networks from scratch. So I like to show you how to create a from zero an emitter, and we'll take care about the emission a little bit more in depth, and then we'll play with the speed, drag, collision and bounces. And we have to see also how the forces and the color works. So that's our basic scene. Let's imagine that we are not using this one and this one and this one. So we go back to a new emitter. So we can have the a new geometry. We go for something really simple. So let's go for we can go back to a sphere. So let's write sphere. Okay. So basic emission tips. Okay, so we have our mesh. Let's go inside, and this one is basic emitter as always. P for the panel about the properties, and we go to play with a polygon mesh. Let's say that the frequency is higher. So as always, something really simple. Let's imagine that we like to emit particles from there, essentially everything manually. So let's go for pop network. We go to connect directly this one. So let's say that this one is the particles generator. And let's go inside. Okay. We have this panel. Everything is done by default automatically, but let's see what happens if we try to do something from scratch. So this one is essentially a dot network. So if we go there and we say, let's say we like to create a dot network. Inside the dot network we have nothing. So you see we can connect there. Let's say that this one is the particle from scratch. If we go to use this one, you see that we have nothing. But essentially there you know that we have the pop objects, this one, we have the pop source, we have this merge, and we have a pop solver. So we have just the output inside the dot network. So let's try to create this one from scratch. So we need a pop object. Sorry. I just used the O key. We need the pop object. So pop object. We need a pop source. We need a pop solver. So the pop solver goes to the output, the pop object goes down inside the solver, and the pop source is connected to the source. So this one is the source, this one is the pop object, this one is the pop solver. Okay, we have everything, but as you can see, it doesn't work. It is doing nothing, and that's just because we have to go there and we have to say how it needs to be tweaked to work. So let's say to use whole points, or maybe we can use whole points. By the way, let's go to whole points, and then we have to say to connect to the first context. So the source guide is right. Let's remove this one and let's see what happens. We have nothing, still nothing. So the first thing to say is that we like to use a different emission type. So we go from all points to scatter on the surface. So now the particles are scattered over the surface, and you see that now they are visible. So let's go back to a better visualization. So inside geometry, let's say that we have points. Okay. So as you see, now it is working completely. So you know, this one is completely working. Here we can say, for example, to have out just the pop object, and that's done. We have the right setup there. We can have a file cache. to control the output, and we can have there an out to say that this one is the output. So let's use, oh sorry, this one is not right. That's it. Let's go there. Sorry again. Okay, and the color, let's say that it's more visible. This one is out particles. This one is connected there, and this one is connected there to create the cache, let's say cache particles. And that's done. We have it. So we can have the possibility to output this particle. So you see, creating from scratch something is really simple. If we go to see this one, it works in the same way as the one we done. Okay? So essentially it's really simple. So let's remove this one. Let's go back there and Control S. So you see that we have, or maybe we can directly save this one as chapter 3. Okay. Essentially you see that we have just to use the pop source, the pop object, and then the pop solver, and that's all. Let's see what happens if we have, for example, something, we like to make some tests for the collision. So let's say that we have a transform node there. Okay, and we can call it fix pause. And let's say that we like to have a translate over the y-axis about maybe 1.5. Then go back there, and we like to make some tests with the collision. Let's use a collision, a collision with the ground plane. The ground plane is something that is done essentially to create some collision by test. So let's go inside merge, and we say that we have this one and this one, and then back there. So you see that now we have a ground, but we have obviously no collision. We can have some different ways. So you know that, for example, we can use the gravity. And we have the particles falling down and collide with this mesh. Okay. Now the problem when you have this kind of configuration, let's say that we have this setup. Okay. Everything goes down there, then we have the gravity, and then we have the output. The main problem is that you have to remember to use the pop object there, because if you have the asterisk, you see that the output from the DOB is also this geometry, this ground. And it means that if you go to cache the file, obviously you will have also this geometry. So remember to set to pop object to have just the particles out. By the way, the simulation will be the right one. So you see, if we go in play, we have the right collision. Okay, let's go back there to play a little bit with the collision to understand how it works. So you see that there we have some information about the geometry. Obviously the ground plane is a specific kind of geometry. For the other collision you can use the static objects, deforming objects to make the collision. By the way, you know, there we have the scaling, we have the color, we have, this is the scaling of the plane for both axes. And then we have some information about the initial state, but more importantly we have the physical parameter. So let's set, for example, bounce to 0. You see that we have just the particles falling down, and that's all. We have no bounces. If we say that the bounces is 5, obviously you see we have a really high bounces because the energy is higher than the one we had to for the animation. The bounce forward is less important for the particles, essentially because there we have just a plane and the particles falling down. By the way, we have also the friction. So let's imagine something. So let's say that we have some kind of rotation. So let's say something like that. Okay, and we can remove essentially the grid. So back there, if we go to C, you see that we have the bouncing, and then we have the particles flowing away. Okay. Let's go back to the first frame and pick again the physical. Let's say that we have no friction, particles moves really fast. Let's try to say that we have a really huge friction, so something higher than before. And you see that something is going in the wrong direction. Let's see if something works better when we have the dynamic. By the way, you see that it is not working. And that's because we have to go back there inside the particles and in the solver. And let's see what do we have there. You see that there we have some information about the particles. So let's go in another context, is the pop object, because we know that this one is the container about the particles. So let's go there, and you see that we have here collision, and here we have the physical properties about the particles. We have the bounce. So if we say, for example, 0, you see that we have no bounces, because this one is the bounciness, the bouncing property about the particles, and here you have the amount of bounciness we can have with these objects, because you know each object can have a different bounce level, so that's why we have two ways to control it. So this one is essentially something like a multiplier, so we can say, for example, that we have 0, 15. So it's really low, and it's not possible to see how it works. By the way, if we go back to 1, we have again the bouncing. Okay, if we say 10, you see that we have a huge amount of bounciness. So let's go back to 1. Let's see what happens if we have the friction, because you see this one is set to 0, and it means that we have 0 multiplier. It is something like a multiplier of the friction property. So let's say 1, and you see that it's working. We have a really high energy about the dragging. So if we say let's go back to 5 for both, because we don't need to control in a different way both parameters, you see that now it is working a little bit better. Let's go back to let's say 0, 5. Okay, you see that it's working better than before. Okay, so that's really nice. So back to the particle properties, and that's all. You see, that's a way to control the dragging and the bouncing. So it's a really simple way to do it. By the way, let's go back to, let's say that there we have no gravity, and we have there, sorry, a pop force. So pop force, and this force is essentially minus 9.8. This way we are creating essentially a gravity force. Okay, so that's really nice. Problem is that you know, in this way we are using this plane. By the way, it's just something we can do with this plane. So what I mean is that, for example, if we have a really small plane, let's go to play, you see that we have the collision with everything. So the visualization is done using the grid sides, but we are talking about an infinite plane. So if we like to have something else, so let's say that we remove this one, and we go back there, and let's say that we have a plan like this one, and we go there to say that this one is rotated. So let's say that there we have also no translation, but we have a rotation. Okay, and then go back there and back in the particles. Okay, so we can take care about, let's say that we have no more stuff from the old project, and we can remove everything. Okay, so we say that this one is essentially a static object because it's not deformed in animation, so we don't need it. Let's go back there, and inside the DOP it's doing something not so nice, but so we can remove everything else. And let's see what happened. You see that we have the right collision as before, but you know, it's okay. Let's say that this one is a little bit different about the scaling. So let's go there, and let's say that this one is essentially over the x-axis, maybe 2 meters. So it's a really little stuff. If we go in the particles, you see that now it works perfectly. Okay, so obviously we can have again the ground plane, and if you like you can directly connect there, and let's say that this one is there. Okay, so we need just to change the position just to have something more interesting. So you see that it is working in a really nice way. We can say that this one has no bouncing, and so it is working perfectly. So as you see, we have a different kind of materials for the collision there. We can have, for example, if we like an higher, let's say that we like to see pixel, maybe pixel is too low. Let's go for 2, maybe 3 pixel. Okay, so you see that the particles are falling down, then we have the bouncing, and then we have the particles over the ground. Now you can see that maybe we have some kind of problem related to the quality about the collision, because here something it's going to be not so precise. So let's say that we have more and particles, let's say 50,000. So we go up, and maybe it's not so bad, but you see we have particles that are falling inside. We can have some stuff we can do, so let's try to see, for example, if we rise up just a little bit the sub-steps there. Let's see what happened. We can go inside, and you see that it's still not so precise. So let's see if we go higher with this one. Maybe the animation is better than the previous one, but you see that we have still something that is going to be not so nice. So let's go back to 1, and let's see what we have there. We have the sub-steps also there. Let's try with 3. And you see that we have still some not so precise collision. So let's go back to 1. Let's go to choose this one, and we see that there we have the possibility to see which is the collision. So let's go out. Let's say that we don't like to display the geometry, and we like to see just the collision guide. And you see that the collision guide is not so precise, and that's because the division sides is low. So let's go, for example, to 0.05, maybe 0.02. It's really high quality. Obviously it will go a little bit slower than before if you have a lot of particles, but the quality will be higher. And just to let you know, if you have some problem with the normals for, for example, if you have inverted normals, you have just to set to on the invert sign. Let's remove the guide there because it's slow to be visualized. Let's go back to the display geometry, and you see that it seems that it's going better than before. Let's try to go inside, and you see that it's really high quality. Obviously we can have still a higher quality there, because we can say, for example, let's go to 001, and if we like, we can have a little bit of offset. So by the way, let's go there and let's see what happened there inside. It is really precise. By the way, you know, if you like, you can have a little offset. Let's try with 01 to see what happened. You see that that's really high, so let's go to 1 centimeter. This is low, and we should have no particle inside or no visible particle inside. Okay, so you see we changed just the resolution about the collision. We have a little bit of offset to be sure that we have the right collision around, and then that's all. It is working perfectly. Something that's not so nice is this kind of bending there, and we can take care about it just rising up the sub-steps there. So let's see, for example, with 5, a little bit slower than before, but that's just really high quality. So you see that we have a really high precision about the simulation. Okay, so it is working in a really nice way. And Ctrl S. Now let's see some basic way to control the particle color. We have a really nice, let's remove first of all. Okay, we have a really nice node. It's called pop color. We can stack there, and you see that in this way we can create the particle color. It's simple. You see we have some possibility there. We have the activation, we have the possibility to choose between some different kind of coloring, and there we have the color. So you can decide, for example, for any kind of color, and everything will works essentially in the right way. So if we go out of there, obviously the particles are colored by green. So that's really nice, because you see there we have the CD, and if we go there and say that we can split this one top button, and there we like to have the geometry spreadsheet. Okay, you see that every single point has a color. Okay, we have the force, we have a lot of stuff we can remove. For example, if we like to save a smaller file, or if you don't need to use some kind of stuff there, we have, for example, the age of each particle. Let's save this one. Okay, so back there about the color, the pop color, you see that we have the constant, we have the random. With this way, you see that we have a random color for the particles. Okay, so we have, when you see that you have some kind of problem like this one, let's reset, and then everything will work in the right way. So we have the random color for the particles, and there you see it's using the vex. Actually, we have no information about the vex. It is not a course or a workshop based on vex, but we will work on something. So now it's using the ID, the particle ID, to control the seed. Here you see that we can change this one, and the colors will be distributed in a different way. We have some possibility, we have some example. There we have the random by ID, random by point. This one is different than before. So the color is assigned based on the PT number, so the particle number. You can obviously write something more complex there, and then there you have the color based on age. You see that the ramp is equal to at an age, and the value is the particle age. So for example, if we say that the particles are limited to have a life expectancy of 2 seconds, we'll have the animation, and you see that the particle color is changing based on the pop color we set there. So we say that the life, when the life is 0, we have bluish. When the life is at the end, we have the white. And if we like, we can add another point and say that there we have a different color, like this one, for example. And this one is really similar to the ramp color used, for example, for particle fluids. So that's really nice. It is recaching everything because we have to take care about the color in the right way. Again, you have some example. You have the normalized age, that is the one we are using. That's the age, so you have a different kind of distribution about the color. You have the speed, so essentially we have to redo to control the speed. So in this case you have to decide also the range. Now the range is between 0 and 1 meter. If you say, for example, 10, you see that the speed is distributed again with a color. So essentially we have a better way to visualize. Obviously we can do lower, we can find a better value. You see that it's distributed in the right way. We have, for example, the 8. So depending on the altitude, we have the right color. So let's say that this one is there. You see that we are rising up. And obviously the problem is that the altitude, the max altitude is set to 8 meters. But if we say 3 meters, obviously the sphere is there and we have a better possibility to control the color in the right way. Okay? If you like, you can distribute the color in, you see, in a simpler way. You can say, for example, let's say 5. You see that we have a better distribution about the ramp. Actually the 8 is based on the at point y axis. You can decide, for example, to use the x is not more the altitude, and it's something more strange because you see that it's coloring depending on the x. If we say, for example, let's use the z and we go back, you see that now it's using the other axis. So you have the possibility to control how it works and how it is behaving. So let's go back to age. That maybe it's the more interesting thing. Let's see, this one. So we have, let's wait for the calculation. By the way, it is working in the nicer way. Let's say 2 because our age is 2. Okay, so we have to take care about it. You can always imagine that if you like to have this kind of setup, we can imagine, for example, to have something nicer, and we can say, okay, we are going to use the age, so right mouse button there, let's say copy parameter, and then we go there, right mouse button there, and we say past relative. Okay, in this way you see that it's connected. Let's remove the 2. It's connected to the pop source live, and if we click again, you see that it's set to 2, but it means that if we go there and we set to 5, then we have 5 there. Okay, so let's go back to something more simple just to see how it is working, and you see that now it is taking care about the 5 about the live. Okay, so let's save and let's move forward. Let's imagine that we have again the force. So you know our actual force is based on the gravity, but we can say, okay, please add a noise forces there. So it is based on chaos. So let's say 5. We have to go back, and you see that now it's moving in a really strange way. Okay, we don't need to be so precise, so let's go back to 1 there. Okay, and we can play. You see that it's really faster than before. So we have a little bit of chaos. The problem is that obviously now when we have the collision over the ground, the particles moves away for a little bit, something like there is a wind. Okay, but we'll take care about stuff like that later. It's not a problem. So let's go back to see how it is working. And that's really nice because we have this kind of chaos that is giving us a really nice way to see how the particles are behaving. Let's see if it's better to use maybe pixel. You see that it's really nice. If we have a higher amount of particles, so it's really huge amount of particles, you see that it's really fast and it is moving with this kind of force. Okay, so the idea is that essentially the movement is really interesting because we see all those particles moving away with this kind of wind. Obviously, if you like, you can have also some kind of wind with the right direction. So, you know, our pop force now has just the gravity, but we can say that over the x-axis we have a force of 1. So it means that we have the gravity force over the ground, but we have also an energy moving over the y-axis. So you see that it's moving up to the right. If we say -2, obviously it will move backwards. So we'll have, you see the wind moving the particles away on the other side. And that's really interesting. Okay, let's stop it. Okay. Something that can be done is, for example, using an expression. So let's say that we have a round, let's say string f, and it means that we are going to use a random number between the frame numbers. So every time the frame number is changing and we have a new random value for the x-axis force. Obviously it's not so simple to see how it is behaving this time, but you know, we can see that we have a randomic energy over this axis. You see that we have something like that. And we can have, for example, we can have a multiply there, we can have everything you like to have there to control the expression. Let's delete the channel. We have back the number 0 because we don't need to have some random forces there. By the way, let's say that we have an energy, let's say -5. Let's use just a little bit less particles to see how this is working. Okay, so we have this kind of wind and it's moving really fast, the particles. Let's go back to points. Okay, so you see that the particles are moving really fast here. Then we have the dragging and some particles are moving over the ground. That's really nice and interesting, you know. By the way, we can say, for example, that we like to have a drag, and to have a drag we have the pop drag. All the pop forces are there, so we have a lot of stuff we can do. We'll try to cover some interesting thing inside our workshop. So now we have a drag force. The drag force is, you see, it's named as I resistance because it's something like a dragging over the air, and in this way you can have a better animation because, you know, we have the drag over the surface with the friction, but we have also the air drag with the drag with the air resistance, and then that's really nice. So let's imagine that it is really high. Then we'll have, you see the particles moving really slow inside the air because there is a lot of drag, so we see more noise coming from the pop force, and we have also the particles disappearing because, you know, inside the 2 seconds of life, obviously the particles have no time to arrive to the ground. Okay, so if we like to have something that is more realistic, we can have 1, and there you see we have the possibility to have also the wind velocity if you have if you like to add some kind of wind there, and you have always the possibility to control the activation. What I mean, you see that every single pop ground and pop force as an activation value, and it means that it is active or it is not active. What I mean is that, for example, if we say that this one has no, maybe this one, the drag, let's say that the drag is 10, it's really high, okay? So let's say that it's set to 0, so we have a key there, and you see that the particles are behaving in the normal way, and then we say that at frame for maybe 39 we have gain 0, and then at frame 40 we have 1, so this one is active, okay? So what I mean, it means that it is moving in the normal way, and then it is slowing down because we have this force active, okay? So you can animate if it is active or not, and if you like you can animate the force, so we can say that at 40 or maybe at 39 we have 0, and then at frame 60 we have 10, so it is rising up with a shift key. We can say if it is linear, okay, nice. So let's go back. So we have the activation, and then you see that the force is moving step by step to rise up, okay? So you can control this kind of effects with a really nice way. Let's say that the max point is higher, and we go back there to say that we have pixel because we have a lot of particles. Control S to save, and let's go, and you see that now it's really nice. And then you see that we have the drag, and you see that there we have some nice pattern over the ground due to the dragging and also to the air resistance. Okay, nice. Obviously the particle system is really complex, so we have no possibility to see how it works. With the cache you have the possibility to say that you like to have a higher amount of cache. Now we have 5 gigabytes. It is inside the cache panel in the DOP. So you can use more there, or you can decide, for example, to save this one. So let's say that we go right mouse button, delete channel, let's say 150, load from disk, and then save. And it is, you see, rendering the cache, and we'll see in a few how it works. So it's done. You see that we have all the information we like to have. So the particles now doesn't need to be calculated again, and if we like we can have an object merge to see everything there, and inside the object merge we can pick the grid, so it should be the extrude volume, okay, and then we can have a merge. So we see how it works in the right way, and if you like you can add also a ground down, but you see that the quality is really high, so we have the possibility to decide how it is working in a really nice way. By the way, you see that there we have a lot of information that maybe are not useful. So you see, for example, we have the age, we have the force, and stuff like that. So if you like to remove stuff before the caching, you can add an attribute delete, okay, it can stay there, and let's say that this one is clean data, and we go there. You see that we have still all the stuff we had before, but we have the point attributes, we have a list. Let's say that we don't like to have the age, we don't want to have the force, the as previous, the ID, the life, P previous, source prim, and source UV. So you see that we removed a lot of stuff. We can go to double check if we have something else there, and you see that we have nothing more interesting for us. So now we have less stuff to be saved. So this one can give us a possibility to have a lower amount of cache there. Okay, so this one is interesting because it cleans up the stuff we have inside the particles. So the last thing I like to show you about the particles in this chapter is related to the emission. So let's go back to the particle. Let's go back to the standard visualization with the points, and let's go back to a lower amount of particles. So, we can decide how the particles are emitted, deciding when the particles are active or not active. By the way, I like to show you some stuff you can do there. So one idea is, for example, to control the constant activation with no animation, but just with the frame checking. So if we write there string ff that stays for frame, and we say equal maybe 15, it means that we ask to have the activation when the frame is set to 15. So you see we have no more particles, and if we go to play, we have the particles emitted. Let's remove the drag just for a moment. We have the particles that are going to be emitted just at the frame 15. You see that we have no particles until frame is equal to 15, as we brought there. We have obviously just 5,000 particles emitted because we have the right particle number, and you have this one. We can say with 50,000, and you see that it's really nice. We have still the wind, and then we have the particles dying, but we can say please stay for 50 seconds. So you see that it's working in a perfect way, and you see that we have still the forces with the wind and the drag working all together. Okay, so let's say that there maybe we have the live. Let's delete this one, and let's say that this one is set to maybe the speed. Let's say that we go a little bit faster. Okay, something like that. Okay, so you see, maybe we can go lower because we have a little bit of white there. So it's working perfectly, If we go back there and we say that we like to have the emission until the frame is meaner, so then 15, you see that we have the particles. Let's try with less particles. So we have the particles, we have the emission, and then it stops automatically. Okay, we can do the same obviously with major. So we'll have no particles until frame 15, and then we have the emission. Okay, and then it is going away with the wind, and we have the right animation with the frame we like to have. So that's something really nice we can do. By the way, for example, you can say to scale up. What do you have there? So essentially now we say that we have this one disabled, so we have 5,000 particles. Okay, but we can say, let's say that we have the emission just at frame 15. So we have 5,000 particles emitted. And we say that we have the scaling attributes that will go to control to have more particles, but it is better to do it. Let's do it with this one set to, okay, and that's done. let's remove this one. Okay. And you see that if we go down there, we have the possibility to have more and more particles just based on the area. So if we say there that we have 500 particles by impulse, and then we go to use this one, if we say 1, we are using the same value. If we say 2, we are losing the amount, okay? But if we go lower, we'll have more and more particles. So we are scaling how much particles are generated just using this value. By the way, you have different ways to control how the particles are emitted. And you know that this one, let's go to the standard emission. Let's go back to 0 and let's say 5,000 by particles by seconds. Okay. And if we change this one, you see that this one is essentially a seed to emit the particles in a different way. What I mean, if we go to have, let's say that we have a merge, and we have the same particle, but we go to use a different color. So let's say, for example, red, and this one is orange, and this one is black. This one can be removed. Let's say that this one is gray. Okay. We go to merge this one, and then we have this one connected. You see that we have the particles are up in the same position, but if we go there and we say 1, we'll have both particle system working together because the points for each particle is based on a different position. Okay, and that's really nice to have different particle system with the same feature but with different position for the particles. Some more stuff that can be useful at the beginning is maybe we'll take care about interpolation later when we have a more complex project to work on. And I like to show you just the possibility to control how much particles are generated. If we say, let's say that this one is not working. Let's say, and we say there, we like to have maximum 100 particles. You see that we have less particles than we thought, because we asked it to have 5,000 for each seconds, and now we are saying that we like to have maximum 10 particles or 100 particles. So you have the possibility to say that you want to have maximum, for example, 5 million particles and stuff like that. And this one is the total amount of points, and this one is obviously for frame. Okay, so other things that can be useful, let's think about it. Just some tips. Let's imagine that we don't want to have the constant activation, so we have no particles there. So you see that we have no emission, and let's say that we have 10 particles. It means that, you know, every single frame we have 10 particles emitted. But you can do something strange. You can say, for example, to use the number of the frame. So you see that the particles are becoming always more and more and more, because it's going to emit the number of particles you have there for each frame. So you see that there we have 1 particles, then we have 3 particles and 4, and the number is there. You see, it is how it is behaving, and it is going to rise up. Okay, so that's a possibility, for example. And as always, you have the possibility to scale up just using the reference area. So you will have an amount of particles there to do something really fast. Let's imagine, for example, that we have 100 particles. Okay, so that's to do some fast test, and then you say, okay, I want to have more and more particles, and you are going to use just this one as a multiplier. You have always to recalculate to see how it works. And in this case, if we have 100 there and we say reference area is 1, or if you set to off, you see that this one is going to say how much particles are generated. So it's a nice, interesting way to have a multiplier. So just some tips to control the particle emission. Then I think we have to move forward to control in a better way the speed, and see how we can work to control the particle emission and the speed to create something more complex than before. So we start to create some nice setup in the next chapter.